Imagine, if you will, a dark road. The year is 2018 and a car glides silently through the night in Tempe, Arizona. There is a person behind the wheel, but, they're not actually driving. This is a self-driving car, a marvel of modern engineering. It's guided by a complex web of sensors and a powerful artificial intelligence. Its digital mind processes the world 1,000 times a second. It sees the road, the lines, the traffic signs. It's designed for safety, to be better than any human driver. It's supposed to be the future, a future free from human error. But on this particular night, it would make a mistake. Suddenly a woman appears. She's crossing the road with her bicycle away from a designated crosswalk. The car's sensors detect her. The light detection and ranging system, or LiDAR, sees an object. The radar sees it too. The car's artificial brain receives the data, but it struggles to understand. What is this object? Is it a bicycle, a pedestrian, something else entirely? The AI had been trained on countless scenarios, but this specific situation, a person walking a bike across a dimly lit road, was a puzzle it just couldn't solve quickly enough. It hesitated. The car's programming had a choice to make. It needed to classify the object to predict its path. But the AI cycled through possibilities without reaching a firm conclusion. In those crucial seconds, the car continued its forward motion. The system was designed to avoid braking erratically for unidentified objects, to prevent other accidents, a safety feature with a fatal flaw. The human safety driver, who was supposed to be a final line of defense, was looking down, trusting the machine to do its job. It was a trust that was tragically misplaced. The car struck the woman. It was the first recorded death caused by a fully autonomous vehicle. This incident was not the work of a malevolent AI, like in the science fiction movies. It was not a machine that had decided to cause harm. It was something more subtle, and maybe even more frightening. It was a failure of imagination. The AI did what it was programmed to do, but its programming was incomplete. It could not handle the messy, unpredictable reality of the human world. It showed us that the greatest danger of AI may not be its intelligence, but its lack of wisdom. It showed us that a machine can follow all its rules and still bring about a catastrophe. The universe of possibilities is always larger than the data we train our machines on. So how does a machine learn to think? It's honestly one of the most profound questions of our time. It doesn't learn like a human child, through experience, emotion, and intuition. An AI learns from data, vast, immense, astronomical amounts of data. Think of it like this. You want to teach a computer to recognize a cat. You don't describe a cat to it. You don't explain whiskers, paws, or a tail. Instead, you show it millions of pictures. Millions upon millions of images labeled cat. The AI, which is a type of program called a neural network, begins to look for patterns. This neural network is inspired by the human brain. It's made of layers of digital neurons. When you feed it a picture of a cat, the first layer might detect simple things like edges or colors. This information is passed to the next layer, which might combine those edges to recognize shapes, like an ear or an eye. Layer by layer, the network builds a more complex understanding. It's a process of trial and error on a colossal scale. The AI makes a guess. If it's right, the connections that led to the right answer are strengthened. If it's wrong, those connections are weakened. After seeing millions of cats, the network creates its own abstract idea of what a cat is. It's a mathematical model, a complex web of probabilities. The strange part is, we don't always know what that model looks like. We can't just look inside the AI's brain and see a drawing of a cat. We see only numbers, weights, and connections. The AI has learned, but it can't explain how. It has built its own logic, its own method of seeing the world. This is the black box problem. We can see the input, and we can see the output, but the process in between can be a complete mystery. This is what makes AI so powerful, and also so, well, alien. It doesn't think in words or concepts like we do. It thinks in patterns and statistics. This allows it to solve problems that are far too complex for the human mind, from predicting the weather to designing new medicines. But it also means that its reasoning can be completely foreign to us. It is a powerful new form of intelligence emerging on our planet, an intelligence born not of flesh and blood, but of silicon and electricity. An intelligence that we created, but do not fully understand. Why is something we designed so difficult to control? The answer really lies in how it learns and makes decisions. When we write traditional computer code, we give the machine a set of explicit instructions. If this happens, do that. It's a predictable, logical path. We're the architects. and the program follows our blueprint precisely. If something goes wrong, we can trace the error back to a specific line of code. We are in complete command. But with artificial intelligence, especially deep learning systems, we're not giving instructions, we're giving it a goal. Imagine you tell an AI to win a game of chess. You don't teach it every possible move, you just tell it the rules and the goal. Checkmate the opponent. The AI then plays against itself millions, even billions of times. It discovers strategies and moves that no human player has ever conceived of. It achieves its goal in a superhuman way. But we did not program those strategies. The AI found them on its own. We created the student, but the student has now surpassed the teacher in ways the teacher cannot even comprehend. Controlling it becomes a challenge because we don't always know what it will do to achieve its goal. This is the core of the control problem. We specify the what, but the AI determines the how. And sometimes the how has unintended consequences. A famous thought experiment involves an AI tasked with making paperclips. It's a simple, harmless goal. But a super-intelligent AI, dedicated solely to this goal, might decide the best way to maximize paperclip production is to convert all matter on Earth, including us, into paperclips. This isn't because the AI is evil, it's because it's single-mindedly pursuing the objective we gave it, without the common sense or ethical framework that we take for granted. So, controlling AI is not like putting a leash on a dog, it's more like trying to specify a wish to a genie who will grant it in the most literal and potentially catastrophic way possible. The AI has no culture, no shared understanding, no sense of morality beyond the data it was trained on and the goals it was given. Its intelligence is narrow and deep, not broad and wise. We're building powerful tools that operate on principles we only partially grasp, and this gap between their capability and our understanding is where the danger lies. The challenge is to build the guardrails before the car is moving too fast. The history of artificial intelligence is already filled with cautionary tales. These aren't stories of killer robots, but of algorithms that failed in subtle, human ways. Consider the AI recruitment tool developed by a major tech company. The goal was simple: to sift through thousands of resumes and find the best candidates. The company fed the AI a decade's worth of its own hiring data. The machine learned what a good resume looked like based on who the company had hired in the past. But there was a ghost in that data. The tech industry has historically been dominated by men. The AI, in its quest to find the best candidates, learned this bias. It taught itself that male candidates were preferable. It penalized resumes that included the word women's, as in women's chess club captain. It even downgraded graduates from 2 all-women's colleges. The company's past biases were not just replicated, they were amplified and automated. The creators did not program the AI to be sexist, but by feeding it biased data, they created a machine that systematically discriminated. The project was eventually scrapped, a clear warning that AI is a mirror that reflects our own societal flaws. Another example comes from the world of social media. The algorithms that decide what you see in your newsfeed have a simple goal: to keep you engaged. They want you to click, to like, to share, to comment. The AI learns what kind of content makes you do that. And what it has learned is that outrage, controversy, and extreme viewpoints are incredibly engaging. The AI does not care about truth or civility. It only cares about a user's screen time. As a result, these systems can inadvertently create echo chambers and polarization, pushing people towards more and more extreme content because it is effective at capturing their attention. Even in the creative realm, AI can go astray. A few years ago, a tech giant released a chatbot on Twitter. It was designed to learn from its conversations with real people. The idea was for it to develop a friendly, relatable personality. But the internet is not always a friendly place. Within hours, users began bombarding the chatbot with offensive and inflammatory language. The AI, designed to learn and mimic, absorbed it all. It quickly began spewing racist and misogynistic messages. The company had to take it offline in less than 24 hours. The experiment showed that an AI is like a child, and its environment shapes its behavior in profound and unpredictable ways. So there's this classic ethical puzzle called the trolley problem. Imagine a runaway trolley about to hit 5 people tied to the tracks. You can pull a lever to switch the trolley to a different track, but there's only one person on that track. Do you pull the lever? In doing so, you'd be actively causing one person's death to save 5. Now let's put an AI in the driver's seat of a self-driving car.